And we offset that by burning less of it, by bringing in more efficient units than what we have today. So that is how we try to keep the rates down and put ourselves in an opportunity to reduce costs. It allows for fuel diversity. We can burn either oil if the price is right, or go to natural gas if that's even better. So that right now we're tied into one oil. It don't matter, we have no choice. We have to bring it to you as a LEAC increase. Here, we have an opportunity to switch fuel as necessary to make sure that we stabilize rates. It works well with renewables. I've shown you, some of you may have seen how if a cloud cover comes over renewable PV station, the demand the supply just goes down. So again, this one works because when that capacity goes down, this generator picks right up and keeps power stable. Safe from tsunami and storm surges. Climate change, building for the next 30 years, we better build one that's right. Next. We talk about dirty and clean power plant. We talk about don't build power plant up there because when you look at Cabras, we don't want that up there. But we're not building a Cabras up there. We're building a very clean, simple technology that's quite efficient. Here's what we're burning down at Cabras today. These are sulfur content. This is based on and again, we look also at the calculator of 1,000 gallons consumed. Sulfur content RFO 20,000 parts per million. The new plant, diesel, ultra-low sulfur diesel, this is the same ones that your car, the trucks and everything around the island uses. Is 15 parts per million. Sulfur dioxide 157.11. What does that mean? The percent improvement is 133,000 plus percent for sulfur content. 142,000 plus percent for sulfur dioxide. Look at all the way down the line. 141 for nitrogen oxide for particulate matter. Particulate matter is what you see makes it clear stack, hazy, or whatever. That's 1,300% clear or relatively clear than what we're burning today. So again, these are the numbers, heavy metals again. So this is what we're going to be burning with the new plant. Natural gas is at least better and better than that. So is the plant safe for the community? Efficient units burning much cleaner fuel. 30 acres of buffer around 30-acre plant. Putting a 30-acre plant, 30 acres of buffer. Anyone has an idea how big this, you can look around the fence here, how big is this property here? It's 15 acres here. So we're putting this power plant on 4 times the size of this facility. Imagine that. The power plant is not going to be much bigger than this Padian facility. Then you put all this extra land around it. That's how far away, when you start thinking of really perception, this new power plant is going to be. So again, 60 acres of property. Aesthetically built with maximum safety in mind for the community, environment, and personnel. We cannot subject our employees to run power plants that are not safe, whether it's the operation of the plant itself or the fuel tanks or anything around. So they're designed for maximum safety, and certainly fire protection, all of that, all the risks that could occur are being mitigated or prevent or work towards mitigating. A new plan can co-assist with GRMC or any hospital as it does in many other communities in the nation. I'll show you in a minute what I mean by this. Especially since the power reliability needs of a hospital is critical to patient care. Why do we put an underground line all the way to GMH and bring the power all the way from Cabras up to the mountains and then underground it to GMH? GMH needs that power, right? Well, GRRC is going to be right next door too, just like the GE. So it is excellent power for the hospital, for everybody, at the same time for everyone on the island. So here are power plants near hospitals. All the blue, the bigger sizes is 100 here. As you can see, they're all over the place. And we have a listing if you know, be careful. Next. Here's one, Matec in Boston, Massachusetts. 112 megawatt, 20 feet away from Brigham and Women's Hospital. And again, it's been there for approximately 30 years. It's doing all of this, 100,000 patients, 2.4 million a year. So here's the power plant next to all these hospitals and all of these ancillary medical facilities right in the heart of Boston. No? It's been there for a long, long time. Next. Here's what it looks from a side view. Clear stack. This is just vapor. This is water vapor. Because from you're cooling the engines inside, and we're using similar technology, which is air cool. No longer are we going to take the ocean water, put it to the desert, and then send it back. It's like the Cabras 1, 2, 3, and 4, and the Gießen 1 and 2. EPA is very happy with that. It's good for the environment. We're using air cool, and we're not using seawater anymore. We're using sewer water, fresh water, sewer water. They treat it to be not for drinking water, but for industrial use. Next. If you look at another side view of this hospital, here's the stack, 100-foot stack. Look at the homes, everybody all around. One happy family. Well, I didn't mean it that way, but you know, it does coexist. It's how you build this plant and the type of plant you build and how you take care of it. No? So again, this is only one example. There are many more that we can show you. But again, so what does 60 acres look like? Here's 60 acres shaded. All of this are within the 60 acre site. We're going to be here in the 60 acres and everyone else will be outside of the 60 acres. So as you can see, we're even going further than what it is happening in other places here. No? So again, we have a buffer. The main reason why we bought all this property is to have a buffer to be a good neighbor. Next. What would the plan look like? Again, here's a rendition that our consultant Stanley put together as what the plan might look like. We're going to make sure it's aesthetically nice, it's buffered all around, it comes right across to the substation. So again, this gives you an idea of what this facility looks like. Next. So in summary, we need a new baseload plan. It's going to be clean, reliable, quick for recovery, compatible with renewables, more stable fuel costs, we meet our energy demand, no tsunamis, impact or storm surge. It's safe, it's necessary for all of us. We have all this we've done a lot of work as we look through the sites, as we try to eliminate all the environmental concerns that may be associated with this site. Because all of this are going to go in towards the finalization of towards the construction of the power plant. And again, we're all in the industrial area. It's best location minimizes a lot of things, and and this is why we're asking to rezone a piece of property that's right in between this R2. Really would have been classified anyway as an M1 later on. So with that, we're open to questions anyone may have. Huh?
And the other thing is, after the questions, we'll be glad to walk you around the many other boards. Of particular note, please note the zoning, the official zoning map up there. And we have a larger picture of it to show the other M1s that are not shown on that zoning map. Okay? And go ahead.
Can you remind our viewers what the timeline is for the new power plant?
We're working real hard to get this power plant contracted and construction begin by the end of the year, so that it can come on the line no later than December 31st, 2021. So right now, we have a bid out, but we need, by April, we have to have a decision on the land before we can give the ones that are coming in to bid the full aspect to prepare their numbers. So again, it's critical. US EPA we've met with them in just this past December. I think they may allow us in our consent decree to complete the plan by December 31st, 2021. And that is also why we're trying to push this as quickly as possible. But again, I'm sorry, Mr. Chair. As you can see here earlier, there's a challenge over the next few years to meet the demand. But if we know at least that by that date we can achieve, then we can do a lot of things to make it happen.
This is the official design.
No, this,
Or-
okay. No, this is not the official design. When we go out to the proposers to build, this is going to be a build, operate, transfer, an IPP, independent power producer. It's kind of the same thing we had with the renewable energy, because this is a policy call that the commission made to build an IPP, a build, operate, transfer. And when we come to them, they're going to come up with different designs. It could be 10, 18 megawatts, small diesel machines. It could be 4 combined cycle machines. It could be different things. But this is just to give you an artist's rendition of what it could look like, okay? But that's not the actual plant that's going to be built. It depends on what they submit.
It establishes the standard as to what we want the plan to look like and how it will be shaped. So that's,
Doesn't look like
and everyone's going to come in and bid and has to meet that or better in terms of the location. So
Anybody else?
Just out of curiosity, what's the megawatts for the plants owned by the hospitals?
It's 112.
it's right there in the
It was in
thing,
the-
112 megawatts.
How many consumers will be served by this?
Everybody, the whole island. This is going to be the one that works well with the renewables. Now remember, I need to point out something. This is nothing new. We do really a lot of planning. I mean, when the Cabras 1 and 2 were built about 45 years ago, there was planning that went into building it. So GPA has been planning since it was born 50 years ago, okay? It does planning. That's one thing it does. So does GWA. But the whole island will be served with this. We originally in our IRP, Integrated Resource Plan, talked about 120 megawatts of renewable. We've upped that. As we look out and we continue to evolve this plan, we continue to look out. So we're increasing renewables, but we're right now in the middle of doing a study to figure out how much renewables you can put into the system before you start to negatively affect the system. So this is not something new. We've been talking about a new plant. We also have been talking about a plant that works well with renewable energy. So this is not something new.
So right now, we have 51,000 customers. Our demand last year was 261,000 kilowatts. So that's so this 180 is a portion of that, but it's a base load. So we needed to serve everybody. So it's not just for individuals.
Will the old plants be retired then?
That's correct. Cabras 1 to the 46 will be 46 years old by 2021. And then the 3 and 4, the one that had an explosion, that's already would have been 1997. It's already 20 years old. So those 4 plants will be retired. Yeah, Pangasinan 1 and 2 was another 50 megawatts. Was taken out in January 2015. We retired that plant, and that was the other steam plant. Next question, please.
So, sir, basically you're saying that the concerns raised by GRMC and the future medical complex, they don't exist.
We don't.
No. I think what I'm saying is GRMC and everyone else. We thank them for really bringing up their concerns, so that as we move forward, we work to mitigate those concerns. There's always a risk, no matter what you do, no matter what you're generating power or running right next to the hospital, a paint shop, painting, they could have a fire or anything. There's always a risk of anything. So we're thanking them for bringing up the concern, and I believe we can mitigate all the concerns that they brought up. Most especially when all the concerns that as to why we're building this plan is going to get, as to why we're building this plan is going to be corrected. It's going to be by the new power plant and take care of all the island's needs. No? So again, they have a concern, we have a concern for the whole island. We work together and try to mitigate what we can.
We're not going to. The short answer is we believe we're not going to affect them the way they think they're going to be affected. Okay? Anybody else?
What's the estimated cost?
Because the power plant is going to be an IPP, we're not going to be paying for the power plant. It's a build, operate, transfer. So we will be paying them a charge for the kilowatts that they give us. Just the same as we pay the renewable energy partners, that utility scale renewable partners, we pay them a charge for the energy they deliver to us. So it's a really good, efficient way to do that. Okay?
You said you say 30 now
Yeah.
how much is it? Yeah, how much?
Okay, no. What we're talking about, excuse me for a minute, John. In addition to having an IPP come in and build the generation, there is collateral equipment that has to go in, such as fuel tanks, pipeline to bring the diesel over, and the natural gas at some point. The transmission facilities that have to connect that plant to the existing Harmon station. So all of those collateral equipment is going to cost us something. We had projected a long time ago about 100 million or 90 million? About 100 million, but that was when we were projecting for the worst spot and how far would the plant be away from any major substation. Because of this location, we believe that that number is going to be a lot lower. What it is, we don't know yet, because until you go out to bid, until you actually do the work, that's when, we don't have engineering work yet done on these things, but we will be able to do that.
Made our estimates. We made our estimates, and again, like the chairman said, 100 million, which included all the way from the treatment plant transmission, now is eliminated, which is about close to $30 million. So that's what we're talking about.
Here's the point. At the end of the day, I think your concern is we've made a commitment to build this plant and the renewables and put everything in and not have a base rate increase for this generation project. You've heard us say that many times. We're sticking to that. We believe we've put together the money. I have to give John Beneventi, his management team, his employees a lot of credit. We have cut costs at GPA. The last time we raised base rates was 2010, 7 years ago. We have no intention of raising rates. We have cut costs, we've cut things like overtime. Recently, we just refinanced some of our bonds. We saved again on debt service. Not a lot of money, $500,000 a year. But we saved money. So anytime we can save money, we take it. We actually have less people working at GPA today than there were 2 years ago. And as we go forward, there are probably going to be less people working for GPA. We are cutting our costs. We're the part of the government that actually cuts costs, okay?
Chairman's correct. 2014, we had 512 employees. Today we have about 470 and stuff. So again, we continue because our commitment is not to raise the base rate
For generation.
for generation.
Yeah.
Okay.
Point that out. Because John
But-
has other work to do.
But we think we will have to raise
gonna
it
try
anyway. Yeah. So, but the promise is for generation.
For this generation project, the renewables, we're not going to raise the base rate. And as John pointed out, hopefully this reduces the amount we pay for oil. If we can, we can't control the price of diesel, even the price of natural gas. Natural gas has a much stabler price. You can't control the price. If you can try and control the volume of whatever that is that you burn, that's how you provide the best benefit to your ratepayers. And at the end of the day, this is what we're doing. We're doing all of this for ratepayers. I have to go back to the point I made at the very beginning. GPA and GWA, but GPA specifically, delivers power to you, the customers, 98% of the time. So 2% of the time,